Good evening. We are looking at a topic in production and operations management, which is called POM. And in particular, we'll look at forecasting and forecasting techniques. Okay. And apart from that, we also build up a little bit and do the inventory management. So we will just meet for approximately an hour from now, so that we see how we are going to progress. Okay. So getting down to forecasting and forecasting techniques. In forecasting, as we get down to forecasting in POM, okay. So as we get down to forecasting, the aspect in forecasting, we look at the following. So the aspect where we look at the regression, okay, analysis, where we are trying to find the regression equation. And of course, there is also the aspect of moving average. So we are moving average. So these are what is covered in POM, in the forecasting, that is. So we have the aspect of regression analysis, getting down to moving average. That's number 2. And then, of course, we have the aspect of exponential smoothing forecasting. So exponential smoothing. Okay, so now there is the aspect of forecasting where we are looking at, we can look at now for now, because we got this piece of work. So we'll start with the regression. So under regression, okay. So under our regression, we will look at the regression line. So in regression, first and foremost, we have X as our independent variable. Okay, so X is independent. So this one is independent variable. What is an example of this variable? It is advertising. And then also you look at even time. Time does not depend on anyone else. So even time is an independent variable. Okay, now what is a dependent variable? Why? This one is a dependent variable. So under this variable, we have e.g. sales. Sales is a dependent variable. If you don't advertise, then meaning that you can't make a sale. Okay. So now the line of regression is equal to alpha plus bx. Then b is our slope. Then a is our intercept. So this is on what we have as we look at this one. So from here, our b is equal to the formula summation of x, y minus summation of x, then multiplied by summation of y over n, then over summation x square minus summation of x square over n. Then our alpha is simply equal to y bar minus b x bar. So this is on the aspect of the getting the intercept and the slope. After you're getting these ones, we need to substitute these in this equation as we find the regression equation. All right. And then from here, we have to look at as the correlation coefficient in forecasting. So correlation coefficient. So this one measures the relationship between the variables. Are we advertising more, but the sales are reducing? Okay, so the formula is given by this one. So this is on the correlation coefficient. This formula to use as we look at the correlation coefficient. So the summation of x square minus summation of x square over n. Okay, then summation of y square minus summation of y square over n. So this is just the formula to use on correlation coefficient, measures the relationship. This one looks at the relationship between variables. Okay. So what we're trying to simply say here is that getting down to an example here. Okay, can we look at the pamphlet where we are looking at finding the, like an example question 3 of this assignment of this pamphlet. Okay, we may want to just find out the relationship between the x and y variables. Okay. Not only that, we can also get down to an example of this one. Okay, where we are simply saying the Rukanga car loadings over a 12-year period are a busy period as follows. So there were the weeks from 1 week to a week 18. So a week is independent, all right? So in week 1, there was a loading of 220. So meaning that from here, we can use the aspect of those weeks up to week 18. And of course, we have the number, the 220 there, 245, week 2, 280, week 3, 275, the 300, week 5, 310, week 6, 350, week 7, 360, week 8, 400, week 9, 380, week 10, 420, week 11, 450, week 12, 460, week 13, 475, week 14, 500, week 15, 510, week 16, 525, week 17, and 545. So now here, if we are to get down to the breakdown, we can say this is our X and this is our Y. Okay, so X and this is our Y. So you can say 1. Okay, so 1, 2, 3, 4, 5. So all these ones, when we get them, in a nutshell, we can even simply say when our X and Y, we can say 1, 2, 3, 4, 5, using the regression equation, 6, 7, 8, 9, 10, 11, 12, 13, 14, all right, 15. So this is our 15. So we can put the 220 here, the 245, the 280, all right, the 275, then we have the 300. We also have the 310. Then we have a 350 here. Then we have a 360. We have a 400. We have a 380. All right, then we have 420. We have a 450. We have a 460. We have a 475. Then we have a 500. So after all this is done, okay, so as we continue, so meaning here, what is going on here is that on our continuation, we can have on this line, so we can even say on continuation, on the X and Y. So you have 16, which is on 510, and then 17, which is 525, and then we have 18, which is 541. So we can find the summation of X, the summation of X here, the summation of Y. Then we can have also the summation of X squared, the summation of Y squared, and the summation of XY. So all these ones needs to be computed when getting down to finding the regression line. So we can enter the data here. So meaning that within here, we should have the column for X squared. We should have a column for Y squared. We should have a column for our XY. As if we are filling up this. So this is how the table is supposed to be. So there will be the column for each one of these ones here that we have. So the table should be constructed like this in an exam so that you can get down to what we are getting to. So meaning even here, we should have these ones. Okay, so we should have the column where we compute these ones. All right, so the most important thing to do in this forecasting is that we really need to enter the data in the calculator. You can enter the data in the calculator first. You have to clear the memory and enter the data in the calculator. Okay, using the linear regression. So the first one is 1 comma. We start from here, entering the data from there. 1,220 m plus 2,245 m plus 3,28 m plus 4,275 m plus 5,300 m plus 6,310 m plus 7,350 m plus 8,360 m plus 9,400 m plus 10,380 m plus 11,420 m plus 12,450 m plus 13,460 m plus 14,475 m plus 15,500 m plus 16,510 m plus 17,525 m plus 18,541 m plus. So now after entering the data like that, getting from the calculator, we are simply saying the summation of X squared is 2109. Okay, we can even compute manually there, doesn't matter. The summation of X is 171. 171, summation of X from there. Then we have the summation of XY is 75. All right, so 75, 713. Then summation of Y squared is actually 2899 581. Summation of y, just y, is 7001, 7001. So these are the values that we've gotten. Now, when getting these values, what happens here is that, okay, if there's a question, somebody should ask a question, please.
Yes, I have a question.
Okay. Yes.
I understand in the introduction, I think I'm behind on identifying the independent and dependent variables. Since it said the correlation coefficient measure the relationship between variables, I assume it is independent and dependent variables. Then how do you determine which values are independent and which one are dependent variables? How did you label them X and Y?
Okay, so like an example here, that's a very good question. So anything else to do with an independent variable, it's a variable that can exist on its own. Like time. Time is independent. It was 7 hours, but
Okay.
it was 7 hours, but now we're talking about going to 20 hours. So time does not depend on anyone. So even a week will not depend on anyone. It will depend on a week, it will depend on a year. To say next year I should get a car. So we are depending on a year. Okay. Next year, my child should begin grade 1. So we're depending on that year. So a year will go. It was January, but this is it. We are now approaching October, or almost now getting to October. So time goes. That's why anything that is independent does not depend on anyone. So you can only do a master's maybe this time. Okay, when time passes, when you can't go to school when you're 90 years, an example. You get a point, right?
Yes.
Yeah, so anything else that if you are talking about advertising, an example, advertising and sales. Sales will depend on advertising. The more you advertise, the assumption is that the more you are going to actually make more sales. So that is just about how we need to identify these variables. Once you identify them, then well and good. All right.
Okay, understood.
Okay. So now, yeah, this is why we're saying the week does not depend on anyone. You say next week I'll go to school. Next week I'll go to school. You will discover that the weeks have passed, but you haven't gone to school. Well, next week I'm going to sell something. Then if you don't sell in that week, you will not make any money because the weeks will keep on going. It will not depend on you. So that's why it is X. And then this was Y. And it was continuing here. This is week 7, where it was ending at 6 there. Then it went to 13, getting down to 18. So it's in a linear line. So these are the ones here. They found 171. This one here, 21 what? These ones were found using the approach that we are actually using here. So those ones were actually found using the same. So these are the values that using combination entering the data in calculator, this one. And then from here, we have to find our B, which is summation of x, y, okay, minus summation of x multiplied by summation of y over n over summation of x square minus summation of x square over n. So you would have filled in the x square, meaning 1, the y square. I'll just finish up the first one. So 1 y square is 220 square, which is 48,400. 400. Then xy is 220. So even this other one, you can finish up. You say this is 4 then 245 square is 60. Okay, so I will not finish up everything. I just want to show manually, or now you can get this 25. Then okay, then the other one is 245 by 2, which is 490 here. So when you are getting this until the other one, then you will be able to get the totals of these ones. Okay, there's that one. I'll be able to show you, or now we enter the data in the calculator as we go. Okay, so meaning that we can put the 7, 5, okay, so 1 like this manually, then minus these ones here, the 171, we are just substituting there. On the summation of y is 7, 0, 0, 1, then divide by 18. All right, then over the square of x is 2109. Okay, then minus 171 square. Then over what? Over n, which is 18. So after breaking down this, you would find that our beta is actually equal to, okay, so the beta will give us the right, so the b is 18 point what? You can find is 18.99. Okay. Of course, 18.9958. Okay. Then our alpha should be equal to y bar minus bx bar. So y bar, we are simply saying the summation of y over n. So our y bar, summation of y, we know our summation of y is 700 what? 7001 over 18. So our y bar we can find. So this is just about what is going on here, which is 388.94. Okay, then similarly, you can find our x bar, which is summation of x over what? Over n. Summation of x, of course, we know is 171, then over 18. So our x bar, we know that is giving us 9.5. Then here we can substitute and get the 388, okay, 388.94, then minus b is 18.9958 multiplied by what? 9.5. So meaning that our alpha here, it will give us the value of 208 point what? 208.48. All right, so now here, this is how we are getting down to this one. So meaning, so this is how they got this 208.4, and then of course they got b as 19. All right, so we got our beta as 18 point something, which is approximately 19 for our beta. So meaning that our equation was going to be y is equal to alpha plus bx So our alpha is 208.4 plus 18.99. So our equation now will be, what will be our equation? Our equation is actually going to be equal to y is equal to alpha plus bx. Okay, so meaning that our y is equal to our alpha is 208, okay, 0.4, then plus beta is 18.99x. So this is it, what goes on here. So this is the way to go for that equation. Now they're saying that use a trend equation to find what? The forecast, all right? We now need to know what is going on here, all right? So what will be, use a way to predict the loadings for week 20 and week 21. So we're supposed to substitute here for week 20. So week 20, when X is 20 now. So we ended on 18 from here. We ended on 18. We ended on 18. Now you substitute X as 20. So when X is 20, what are we going to find? The value will be what? So this is why we are simply getting the equation now and substituting, okay, plus 18.99 on our X is 20. So please, this is what goes on here. So 18.99 by 20, then plus the 208.4. So we are simply getting 588. So similarly, even if they want us to find for when X is now 30 or 25, you can keep on substituting in the equation to get the value. And of course, getting down to this, we can use the R, which is this expression, to find the relationship, substituting the variables that we have to get our R. Substituting here, so using this as the task here, we should find our R, but when you have entered the data in the calculator correctly, you can get our R should be using that formula. Our R, the answer should give us the 0.99. So 0.999, which means we have a very strong relationship because it's very close to 1. So a very, very strong relationship because it is close to 1. So how you get that one? Okay. So between X and Y, we have strong relationship. So this is just the starting point or the forecasting. Of course, we'll be building up as we go. All right. So I want us to look at a different subtopic altogether, but this is just about one thing that I need to make a mention about the starting point of forecasting in terms of the regression equation on X and Y variables, and as well as just using the correction coefficient. Using this equation, we need to find R, and the answer should give us this one. So in your own time, please try to go through and find the R at 0.99, and it's very close to 1, which means we have a very strong positive relationship. All right, so I want us to do the second part of this question from here. Question 4 is what I want us to do. All right, we will be ending on question 4. This question 4 is on inventory management, because I want us to end on this question So just do this question number 4, then we wrap up our today's class. Okay, so inventory, I mentioned in the other class that inventory means stock. Okay, so inventory means what? Stock. So we have the advantages and disadvantages of keeping stock. So of course, we are explained here in the other class where you say inventory means stock. We have the advantage, that's what the advantage of keeping stock. You keep stock so that the firm does not incur ordering costs. They are avoiding every time to order. You are keeping stock because you don't want to incur the stock out. You don't want to lose business. Every time that customers want to buy talk time from you, they actually need to find that you have the talk time. You also want to keep stock so that you maintain the customer's goodwill, which is just created between the customers and the business. Now, the disadvantage would be that the firm will be incurring the carrying cost, the cost of paying warehousing salaries and wages, the insurance of stock, and then also paying for the floor space charge per bag in the warehousing. Inventory may also be damaged or spoiled, or it may be out of date for inventory obsolescence. All right, so today I want us to look at one model, which is called the purchasing model, the production model. The production model, okay? So under production, inventory, we are looking at model 2. Okay, so under this model 2, which is the called production model. So under this production model, what we are simply saying is that the firm does not want to continue buying. They want to produce their own goods. So we have economic lot size, which is equal to 2ds over C multiplied by P over P minus D, the square root. So this is economic production size or economic lot size. ELS is called economic lot size. So this is economic lot size. Lot size simply means production size. So economic lot size. All right, so then P is daily production. So daily production, okay. Then what happens to the small d is daily demand. Daily demand, daily demand is our small d. Okay, so this is what we have concerning these ones. Then S is setup cost. For this one, it is called set up cost. All right, so this is what goes on. Then D is annual demand. So this one, we have our annual demand. All right, so this is what goes on. Then C is our holding cost. Okay, we have, this is our holding cost. And I have to make mention here that this is the same as Q. And when this is wrong, it may affect almost everything. Then we have number of production runs. Number 2, number of production runs is equal to D over Q. number of production runs. Then we have number 3, length of production run, length of production, or time taken to produce the batch. So length of production is actually equal to Q over P. Then we have cycle time, time taken between production. So cycle time is equal to Q over D. So we have a Q over D multiplied by the days of the year. Days of the year. Then we have maximum inventory. Maximum inventory is equal to P minus D, then multiplied by Q over P. All right, so this is about what we have concerning the maximum inventory. Now we are getting down to the other one, total stocking cost is actually equal to Q over 2, then P minus D over P by C plus D over Q on S. Then getting down to the last formula, total material cost is equal to Q over 2 on P minus D over P by C. All right, then plus D over Q. Okay, so D over Q on S, then plus SC. All right, then by what? By D. SC is the unit price, then by annual demand. So these are the only formulas that we use as we look at the production model. That's all. So getting down to the question here, all right? So the question that we can look at is this one here. A company is about to begin production of a new product, so meaning that they want to produce their own goods, all right? The manager of the department that will that will produce one of the components for this product wants to know how often the machine used to produce the item will be available for other work. The machine will produce the item at a rate of 200 units per day. So that is our P. Okay, this 200. All right, so our P is 200 from there. And we have specified that this is a production model. So our P is 200. Are people with me so far? Then 80 units will be used daily. 80 units will be used what? Daily. What is the daily demand is 80 units. All right. That is just what we have there. So we have 80 units will be used daily. All right. And then assembly will take place 5 days a week, 5 days a week, 50 weeks a year. 5 days a week, 50 weeks a year. So let us find the workings here. All right. So what we are simply saying here is that our daily production is 200. Daily demand is 80. These are units. All right. So even here, these are units. So meaning how many days? Gave 5 days a week. 1 week is equal to 5 days. That's what they are giving us. How many weeks are we having? 50 weeks. Which is equal to X. So meaning that our X is equal to 5, okay, multiplied by 50. So our X is giving us what? 250 days. So our annual demand is equal to 80 multiplied by 250 days. So our annual demand, 80 multiplied by 250, because the daily demand is 80 units. So meaning that we have the 20,000 units as our annual demand, 20,000 units. So please take note of this. All right, so after this now, what happens? We have the other information here. Holding cost is 10. Our carrying cost is $10. The cost of spoilage, warehousing, salaries, and wages. So let's find the setup cost now. Clean up, when cleaning up for production, that's S. S is the setup cost for production. Cleaning up, all right. So meaning that the manager estimates that it will take almost a full day to get the machine ready. That's the setup cost at a cost of 300. So that's the setup cost, clean up and putting things in order. So it's a 300 here. So as we do this now, we can find the first one. What is the order quantity? What is the production lot size now? Okay, so here we know from here now that we can say economic lot size is equal to 2ds over C multiplied by P over P minus D. So of course, this is a square root. So our economic load size is equal to 2 multiplied by the demand is 20,000. Okay, then multiplied by 300 over 10. Then multiplied by 200 over 200 minus 8. So our economic lot size is equal to, so we can sort out that 2 multiplied by 20,000 by 300 divided by 10, then multiplied by 200, divide by 200 divided by 120, so divide by 120, then the square root answer there. So we are simply saying our economic lot size is 1,414.5 21 units. So on the economic production size is 1,414 units. This is what we have. Okay, so now from there, we need now to confirm it. So this is what they looked at. This is our production size. Are people following so far? Are people with me? Are people listening? Are people getting?
For me, I'm a bit behind.
We are behind.
Okay, so under question 2, first and foremost, we are looking at production. So in production, we said when producing your own goods, it's model 2. So it's called the economic lot size. So which one the aspect is where first of all we look at this formula. So this is the formula there. So here our P is our daily production. D, a small d is a daily demand. The capital D is our annual demand. The C is a holding cost. And then S is the setup cost. So from here, this economic lot size is also called, it's a quantity that you need to produce at a time. Formula 1. From there now, we get down to the second one, which is number of production. How many times are you going to produce to meet demand? Okay, so this is called number, okay, number of production runs. Okay, so number of production runs. So it is, this Q is economic lot size. The first one that we use the formula from here. Then length of production, time taken to produce a batch. So this is time taken to produce a batch. Time taken, okay, to produce the batch. To produce the batch. So the most important thing here is for you to understand the formulas. Are we together?
Yes.
So here, the problem is just to understand the formulas. Once you understand the formula, you just see. So this P is the same P that is here on a daily production. And then this is our daily demand. So everything here, this Q is economic lot size. So meaning that if you get the first answer wrong, it may affect you all the other answers coming down. So
Excuse me, sir.
Yes.
In that formula, in the square root, the P, the 2ds over C times the P over the P minus D. Now the P there on top of, yes, that one.
This one.
Is it the same as the other P that is under that one?
Yes, it's the same one.
Okay.
It's the same P. So that's why if you see after coming down here, it's the same P which is here. It's the same P here. It's the same P on this one. It's actually the same P on this one. So as we are sorting out from here, it's the same P even here. It's the same small d here. You know what I mean?
Okay. So in yesterday's class,
that one was model.
I noticed. Yes, that one was model 1.
It does
and
not.
This is model 2. So I'm just looking at the formulas.
They are totally different. This other one was just like for model 1, it was just 2ds over C. That's all for model 1. Are we together?
Yes, sir.
So model 1 model 1 and model 3, they use the same formulas because they can only give you the discount when you're buying. They can only give you the discount when you're buying. So that's why model 1 and model 3, we use the same formulas. But model 2 has its own formulas, like the ones I'm giving you now for model 2. So this is how we are looking at this. So meaning, when we say economic lot size is a production size, where we simply say the square root of 2ds over c, then multiplied by everything else is in the square root form, then multiplied by p over p minus d. So this is only for production. Please take note of this. Okay, so this is only when they mention about production. That's why in this question, they have told us that the company is about to begin production of a new. So meaning here, the machine will produce the item at the rate of 200 units per day. So this is the daily production. Are people getting me now? Excuse me, are we together?
Yeah, I'm following.
So this is our daily production is 200. Then here it says 80, not 8, but 80 units. It was supposed to be 80 units. 80 units will be used daily. So our daily demand will be 80. So 80. So as you get down, this formula may mislead you somehow. You may make a mistake on it, but it's the same one, the one I'm from explaining. This one here, it's the same. Okay, but all of them, they are just in the square root. Now, what is next is that you need to know that the cleanup holding cost, our C here, is what? Is 10 from there. Our 10 was given, which is the holding cost, which is 10. Now, we are setting up for production, which is setup cost was 300. Then how do we get our annual demand? Our annual demand came in because here are saying that assembly will take place 5 days a week. So in a week, we have only 5 days. All right. So 1 week, you're only working for 5 days, maybe Monday to Friday. And then how many weeks are you working? 50 weeks a year, meaning that you can sort out this one. Okay. The annual demand was hidden here. So it was need for us to find our annual demand, which is a cardinal thing that we're supposed to look at. So our annual demand here, we can forget it this way because the assembly saying 1 week as 5 days. So we are working only 5 days a week. Are people getting me?
Yes, we're getting you.
So 1 week is 5 days. So for 50 weeks, how many days are we going to have? 250 days. Now, our daily demand is how many? 80 units. So meaning you can find our annual demand, all right, which is 20,000 units. This is where the 20,000 units came in. Is that clear up to that level? Is it clear up to this level where you're getting the
Yes, yes.
So it's just because of this breakdown, we are converting the weeks because 1 week we're only working for about 5 days. That's what they have told us. And then 50 weeks a year, meaning that we have 250 days in a year. And then we can now multiply by the daily demand to get annual demand. So meaning that from here, there's need now that we sort out substituting the figures inside here. We are getting this is our Q, our economic lot size. Is that clear up to this level? Is it clear up to here?
Yes. Yes, sir, it's clear.
Oh, okay, thanks very much. So
Sir, the 200, we were given the production, right? We were given this 200 in the question.
The 200, let me show you where it's coming from. It's here. They're saying that the machine will produce at the rate of 200, this one here.
Okay.
You've seen the 200?
Mm.
And then 80 units will be used daily, so meaning that's our daily demand. So
Yeah.
it's just a matter of substituting in the equation there, in the formula, and then we got those ones. And after getting that, if this is correct as our Q, then you will know that you will get everything correct, because it's just the one that determines here, because you're going to use, ask you to get the number of production runs, you just substitute here and get the value. All right. Then for length of production, we also use this formula. Cycle time, this formula. Maximum inventory, this formula there. And then, of course, the total stocking cost, the TSC simply means total stocking cost. We can just substitute there. The total material cost, we also substitute. So getting down to the other question here, it says, what's the length of production run? Length, which is equal to Q over P. Q over P, that's the formula for length of production. Our Q is 1414 divided by 200. So how many times are we going to take to produce the batch? Because per day we are producing 200 units. So 1414 divided by 200 is 7 point what? 7.07. This is what we have. So now, when I ask you to get inventory build up, if there is aspect where the examiner would ask you to get inventory build up, so inventory, when you're building up on inventory, it simply means that you are producing more than demand. So it's equal to P minus D. So that's inventory build up. So meaning it's a 200 minus the 80. So the inventory build up here on this one is 120 units, which is good for business, because when you are producing more than demand, is better so that customers can come tomorrow and demand some more remaining units. But if you're producing less than demand, next time customers will not come, because they would think you don't produce accordingly, you don't produce enough, so they may go elsewhere to look for what they need. So as we are looking at inventory build-up, it is a 120 units. So this is about what they want. All right. So here we are getting down to this other one says, if a manager wants to run another job between runs, okay, and needs a maximum of 10 days per week, will there be enough time? So here, let's find what we need to do is we can find the cycle time. Cycle time is equal to Q over D multiplied by the days of the year. So our Q is 1414 over D. This is multiplied by the days. So the demand is 20,000. Okay, then multiply by 250 days. So 1414 divided by 20,000 multiplied by 250 is giving us okay, it's giving us the maximum they gave us here is 10 days. So an example here we can say, so as long as we have this point here, our cycle time is giving us 1414 divided by 20,000, then multiplied by 250, which is giving us 17.6. 17.6. Okay, for 20.67. So here they have only the max minimum of 10 days per cycle for the other week. And then we have found 17.67 as cycle time. But before this, we can first and foremost also find the maximum inventory. So maximum inventory is equal to P minus D multiplied by Q over P.
So sorry, what are we finding here?
Okay, here we are, the question says, if the manager wants to run another job between runs, okay, between what? Between runs.
Runs.
And needs a minimum of 10 days per cycle for other work. Will there be enough time? So first, what we need to do is we need to find the maximum inventory level first. When you find the maximum inventory level, then we will pick it up from there. Okay, so the maximum inventory will be, so this is the one we are trying to find first. So maximum inventory, we are simply saying, we getting down to this. What's our P is 200. Then minus 120. Then multiply by the 1414 over what? 200. So what is our max inventory? So maximum inventory will be what? The calculator you can say is 8 there multiplied by 1414 divided by 200, which is giving us, okay, so that is the, sorry, this is the, our D here is what? 8. Our D there is what? 8 there. So it will be 200 minus 8 multiplied by 1414 divided by 200. Okay, so we are getting what? 848.4. So what happens now after you find maximum inventory? Let us now say on average demand. What will be our average demand? Our average demand from maximum inventory will be actually equal to
Divided by 2.
848.4
over 2.
We can divide by 80 units. We are the 80 units there, which is giving us what? 10.6. So 10.6. Okay.
Why can't we divide by 2, sir? Why is it wrong to use 2 when we talk of average?
The 2 is there's nothing wrong there, because the 2 we can use it, but the reason is because they are saying they've given us the 10 days. All right. So here they said if a manager wants to run another job between runs of this item, one needs minimum of 10 days per cycle for the other work. Would there be enough time? So that's why we have divided by 8 to find the number of days. Then we compare with what? The 10 days that we have. So meaning that we will actually not be enough time, because we have actually, so here, what is happening now here is this. We are going to have the 10.6 days, which is the one that we have calculated here, which is the 10.6 days. Compare this one with the other one, which is the 10 days that is there. So the difference between the two would be, okay, 10.6 minus 10. We are getting what? 0.6. Okay, so what we are trying to say is that if we need the minimum of 10 days, okay, if we need the minimum of 10 days, we'll just compare 10 days and what we have found here on average, using the average demand of 8. So the 10 days will not be enough. We are supposed to have 10.6 days, which is approximately 11. So this is what we would have gone for. All right. So the 10.6 is the demand which was supposed to be there. So on maximum inventory level that we have here, it's the 848.4 units. Then because we are given the 10 days in the question, that's why you're comparing. Excuse me, that's why you're comparing the 10.6 that we have and the 10 days. So the time that was supposed to be allocated was 10.6, which is approximately 11, not the 10, which was there given in the question. So we're just comparing the 10 and the one we have found there. But when they just ask you, if this 10 was not there, when they just ask you to find average inventory, would have just divided 848 by 2. You get my point, right?
Okay.
If they just ask you to find average inventory without these days being there, would have just said average inventory is actually equal to max. Okay, max, then you divide by 2. This one is I'm not saying that what you said was wrong. No, this is correct where we say average inventory equals maximum divided by 2. All right, so I think you have understood that.
Yes, sir.
Okay. So we can end the class for now, unless there are other questions. So we have run through the forecasting and we have also done the inventory management. And today we just looked at because you see these formulas, the ones I've given you to do with the production model. The most important thing is for you to understand these formulas. They are just 7 formulas under production. So you have to know how to convert the daily demand, how you can get annual demand using the information that has been given in the question, especially the question that we are from looking at, which is this question. So make sure you go through it.